This is the Unit 2, Segments, Lines, and Angles. Preview video 2.1, Graphing of Lines. Take a moment, sit tall, and inhale. Deep breath, hold. Exhale. We are right here. I recommend you have a straight edge handy today, so get a straight edge. We're going to be talking about graphing of lines. So the vast majority of this should feel like kind of a review, slightly. But first, we're going to do a review of radicals. I really want you to get through this page and if necessarily, wildly guess. Work with the pencil, take you about 30 seconds. Then get out your red pen and get ready to correct. Pause the video. Welcome back. Get out your red pens, get ready to correct. Root 2 times root 2 is 2. 5 times 2 is 10. Root 5 times root 5 is 5. 6 times 5 is 30. Root 5 times root 5 is 5. 5 times 4, 20. Root 3 times root 3 is 3. 8 times 3, 24. What? Root 6 times what is 6? That's root 6. Something times 2 root 5 is 10. So you want to get rid of that radical. And so you times by another root 5, which is 5. And then 2 times 5 is 10. If you got those correct, star a smiley. Anything incorrect, write yourself a little note. What are you going to remember next time? We're going to be talking about graphing of lines, so your vocabulary. Rate, slope, y-intercept, x-intercept, slope-intercept, point-slope. What is a linear equation? Remember, linear means a line. An equation means two things which are equal. So it's two things which are equal that make a line. And it's a set of data points to create a predictive formula and corresponding graphs. All lines communicate something. Now, to review some basic properties of lines, would be the most important would be slope. Slope is the tilt of a line. Two parts to slope, the rise and the run. Rise is vertical, run is horizontal. Together, they describe slope. So slope equals rise over run. We read graphs from left to right. From left, hold up your left arm, left to right. That's how we read graphs. So your left arm, elbow to fingertip, left arm, left to right. So if you tilt upwards from left to right, that's a positive slope. If you tilt downwards from left to right, it's a negative slope. Horizontal. Now remember, we're dealing with rise over run. So a horizontal slope has no rise. It has no up or down. So it's a 0 over a number. So 0 over anything is 0. So 0 slope is a horizontal line. Once again, rise over run. A vertical line has no left-right motion. It has no run. So you have a number over a 0. A 0 in the denominator is undefined, also known as no slope. So a vertical line is undefined. Vertical line, undefined. Other terms you need to be familiar with is the x and y intercept. The y-intercept is where it crosses the y-axis. So our y-intercept here is the point, and it's a coordinate point, 0, -3. So on this graph, 0, -3 is the y-intercept. Our x-intercept would be 4, 0. So y-intercept where it crosses the y-axis, x-intercept where it crosses the x-axis. Now this looks tricky. It's not. Let me show you the most common mistake here before I show you how to do it correctly, because I want you to get the common mistakes chucked out. X equals -3. Students like to do this. They go 1, 2, 3, x equals -3. Ta-da! I'm done. No. This reads all the points where x is -3, something. X equals -3 is all the points where x is 3. All the -3, excuse me, oops, it's -3. I even graphed the wrong thing wrong. It's over here. That would be the most common wrong mistake. Ta-da, we're done. Okay, great, negative. So all the points where x is -3 looks like this. All the points where. That point right there is -3, 0, -3, 1, -3, 2, -3, 3, -3, 4, -3, 5. So x equals -3 is a vertical line. X equals -3 at -3. X equals 5 is all the points where x is 5, so we start at 5. So I have 5, 0, 5, 1, 5, 2, 5, 3, 5, 4, etc. So it's a vertical line. X equals 5. And of course, x equals 8 is all the points where x is 8. So 8, 0, 8, 1, 8, 2, 8, 3, 8, 4, 8, 5, and the like. X equals 8. So all x equals a number lines are vertical lines. Back to graphing using the slope-intercept equation of a line. Slope-intercept, you commonly know this as y equals mx plus b. B is the y-intercept. Step 1 is you make sure y is by itself, which we already have here. Step 2, we're going to write the equation right underneath it. Always write the equation right underneath it. Y equals mx plus b. Now we establish what is our b. Our b is +3. That is the y-intercept. So our y-intercept starts at +3, which is 0, 3. Now my slope, be very careful here. It looks like my slope is -3. But remember, slope is rise over run, over. So anytime you have a whole number, you must put it over 1. Our rise over our run. You look, and I know that this is going to be a negative line. Why? Because that's -3. So just kind of do a quick sketch. I know my line has to tilt downward from left to right. It has to tilt downward. So I do this. I rise 3, 1, 2, 3, and I run 1 to the left. Or I could drop 3, and I can run 1 to the right. It's the same slope both ways. Then you connect your dots. Y equals mx plus b. Let's do another one. There's my slope. And you're like, my b's not there. What's up with that? Well, that means your b is going to be a 0. So we're starting at the y-intercept of 0. And my slope is positive, which means I'm going to go up from left to right. So I do a little baby sketch here, left to right going up. And my rise is 5 and my run is 3. Or I can go down 5, over 3 this way, get the same answer. Let's try one more. Our slope is 1/3 positive. Our b is -4. So we start right here. Our rise is 1, our run is 3, little baby sketch, and we know it's positive, so it's going to tilt that direction. So we go up 1 from here, run 3, down 1, run 3. This page, I like you to try completely on your own, then grab a red pen, and come back to correct. Pause. All right, welcome back. Now this first one, you have a red pen, totally okay if you got this wrong. I didn't show you how to do y's, but it's the same process. It's all the points where you have a -6. So it's something comma -6. This one is something comma 3, and this one's going to be something comma 7. All the points where y is -6 looks like this. 0, -6, 1, -6, 2, -6, 3, -6. Therefore, y equals -6 is a horizontal line. This one, starting at 3, 0, 3. 1, 3, 2, 3, 4, 3, 5, 3, etc. Goes like this. It's a horizontal line. That is y equals 3. Y equals 7, starting at 7, 0, 7. Let's just go giggles. Let's go left. -1, 7, -2, 7, -3, 7. All the points where y is 7. This one, how'd you graph that? Y equals mx plus b. My slope is -3/2. and my intercept is positive 5. So starting at the 5, I know it tilts downward from left to right. So now if you go rise this way, you're like flying off the graph. So that's why it's important that you understand you can go both directions. So my rise is 3, 1, 2, 3, and my run is to the right 2, and the reason why it's to the right is I want to tilt downwards from left to right. Now I'm going to give you an example. Remember, an equation of a line, it said it had predictive qualities. Predictive qualities. Let me show you what this looks like. Ready? I'd like you to put your finger right there. You are by yourself. There is no one to watch you, but you're going to do what I tell you to do because you are amazing and you trust me. Put your finger there, and you're going to read with your lips moving out loud. Go. Let's underline our key words here. We have a debt of $1,200, 3 months, and we have a debt of $800. At this rate, how long would it take to pay off the debt? Express your answer in y = mx plus b form. It's really important. When you see the rate, rate is code for slope. Rate is code for slope. You'll see that, like, how is that slope? I'll show you in just a second. When we're dealing with XY graphs, you're dealing with the data point of cause and effect. Cause and effect. Cause is what we call the independent variable. Effect is the dependent variable. Here's a common cause and effect. Okay, when a pot of water is heated up to 100 degrees Celsius, it starts boiling. Here's your fire. The cause is the temperature, the effect is the boiling point. So in this case, the cause, what does not change, the cause is going to be time. So in this case, time. And the effect of the time is debt repayment. So time is our x coordinate and effect is our y coordinate. Watch carefully. You have a debt of $1,200. Now, that's the starting point. So time is 0. And your debt is, at that moment, when you first start this process, is $1,200. After 3 months, 3 months, your debt is $800. And what we're being asked to find is at what time, and our expression here is months, 0 months, at what time, how many months does this become 0 money? That's the question. And we want an equation. So let's start with our 2 data points. Our 2 data points is this. At 0 months, we have $1,200 in debt. Notice the negative sign. At 3 months, we have $800 in debt. Let's graph these 2 points. I'm going to take this and just capture it and bring it over. So 1 is at 0 months. Notice what it says right here. Funds in, actually that should say hundreds. Funds are in hundreds, not thousands. So at 0 months, we owe $1,200. So our first data point is 0, negative $1,200. Our second data point was after 3 months, we are at $800 in debt. So that's 3, negative 800. We want to draw an equation of a line. To get an equation of a line, we need y equals mx plus b. We already have our b. Our intercept of this line is going to start us at 0. Our slope is rise. Rise is the difference of the y's. The difference of the y's over the run, which is the difference of the x's. So difference, subtract. So right here, the difference of the y's, I'm going to have negative 1,200 minus negative 800 over 0 and 3. Double negative makes a positive, and that ends up being negative 400 over 3. But because we are working here in hundreds, see your 1, 2, 3, 4, 1, 2, 3. So my rise is 4, my run is 3. So that reduces, because we combine that by hundreds here, is going to be 4/3. So my equation of my line is actually y equals 4/3 x plus 0. Now if I graph that line, rise 4 over 3, I'm going to do another one, rise 4, 3, 4 over 3. And I get a straight edge here. Graph this line perfectly. What we're asking is, when is the y going to be 0? When is the y going to be 0? 4/3 x. And you can see right there where it crosses is at 10 months. 10 months, the y becomes 0. So that is an example of how we use equations of lines to predict something. Take a minute on your own, summarize what are the 3 key concepts from this lesson.